Will it be a pavement or a sidewalk? When I finally lay my eyes on you, someone I've already loved, will you find your way out of the blue? Will it be my flat or your apartment? When I finally realize I do, will we meet on Baker Street or find ourselves on Melrose Avenue? I don't know who you are, but I'll save you a seat. Hang my coat on a chair next to me. I try to reassure the waiter, say you're down.
Okay, all right. So let's start solving problem. This is the problem that I'm going to solve right now. Tomorrow I have two exams of microeconomics and parameterized complexity. Unfortunately, I'm not very good at either of them, so it's going to be really big deal for me to be able to give those exams basically. Let's just quickly update our timetable slightly. So I've done this exam. I've done this also, and now I have to study microeconomics. Basically, I have to study microeconomics until its exam. So let's just assume that this is fine. पहले वीडियो BTP का काम कर लो कौन है? Thanks for saying hi. I appreciate your efforts. अब मैं जब stream yes. By the way, thanks for subbing. I don't know तुम क्या कर रहे हो, कहाँ से कर रहे हो, but thank you so much for um, giving me free subscriptions. I'm going since you are the only viewer right now, and I have something to spill. I will spill it. Okay. So thanks for subbing. Thanks for making 47 subs. Sooner I will be doing something um, really interesting on this channel other than streaming. So there's going to be something really big जो कि बहुत जल्दी आने वाला है. Just give me about a week and there's going to be something really interesting coming up. Hopefully you'll like it. Abhi, just in a week after the exams. Thanks for subbing and now you can do BTP. Thank you so much. Okay, अब मैं question पे ध्यान देते हैं. तो question है given the root of binary tree, return the average value of nodes on each level in the form of array. Average value of nodes on each level, like that's a very simple answer. That's a very simple question. I can just solve it using level order traversal. What we are gonna do here in this case is that we're gonna have a DQ. So let's just import it from collections. From collections, import DQ. This is a doubly-ended queue. Now we're gonna make a DQ of the first root, and next thing that we're gonna do is to run a while loop until this DQ is not empty. And now we're gonna get the front of the DQ as q dot pop left, and then what else do I want to do? Yes, I want to check the length of the queue. Um, so length of the queue is nothing but L, and now I'm gonna say while L, let's subtract 1 from L. Yes, I have extracted front, so let's just add it to the answer, front dot val. All right, no, so I need to add the average of that, right? So for now, let's just say our temp equals to front dot val, count equals to 1. Okay, now we are here, and now what we're gonna do is inside of this loop, I'm gonna run this loop until L is not empty. I'm once again going to get F as the front of the DQ, and I'm gonna say that let's add this to the temp, and let's increase the count, and let's also say if f dot left, then q dot append f dot left, and if f dot right, in that case I want to append q dot f dot right. Right, so that l minus equals to 1. That's what I want to do. And right here I'm gonna append temp upon count, or count. So this should work, except the last thing that could create a problem of some sort. I'm not sure if there's gonna be any problem. Let's see. It just gives me 3. All right. The reason is because the length is now empty. So what we can do is we can save this, and we can have this as 0 and 0. Now this can also work, maybe. Yes. The last thing that I want to make sure is if root is none, in that case, all you're going to do is return an empty array because your root is actually none. Now I can submit, and this should be all. For this particular problem, yes, there it is. Now we are on 2 day streak, and I'm really excited about this streak. By the way, I have to end the stream in between because I have to go and study for microeconomics um, whenever I feel like. So I have some time before that. तब तक के लिए let's find a hard level question and let's try to solve it. I'm not really sure if I should find a hard level problem because I might be leaving in between. So let's just find a medium level problem. Or what we can do is we can probably finish up this Amazon SD sheet because that's important for us. So let's just finish this sheet up. All right. So the problem is max sum of n and non-adjacent nodes. Yeah, I was working on this problem in the last stream. I remember, not the last stream, a stream that I did about 2 days ago. So today is 30th stream. By the way, I'm on 30-day streak. I have been streaming every single day for past 30 days, and it's insane. I cannot tell you how hard is it for me to stream every single day. Very relatable because whatever thing that you're trying to do, it's really hard to do it every single day for continuously for a long time. Especially because right now I have my exams going on, and ideally I should not be focusing on DSA right now because I have subjects to focus on. But anyways, so maximum sum of non-adjacent nodes. Let's talk about this tree itself. The tree, I'm just gonna draw the tree real quick and try to figure out a solution for this problem. I do have one solution for this problem, and I can do that, but I want to find a better solution. One obvious solution would be to check all the possible ways and just return the answer. And since checking all the possible ways would take a lot of time, I would want to use inbuilt function cache from Python that would cache my output and will make the time complexity such that the answer could be submitted. So that is something that I can definitely do, but I still wanna like find out some other possible way of doing it. So this is the tree, and now I have to find, okay, non-adjacent nodes. All right. So let me think for some time. Then I will come up with a solution and talk to you about it. Hmm. Maximum sum of non-adjacent nodes. At any point, if I know, for example, so I'm trying to write a recursive solution for this. So if at any point I sort of know that my left and right, what are the maximum value that I can get on the left, what is the maximum value that I can get on the right, subtree, then I can sort of say the answer is going to be root dot value, right? The answer is either going to be root dot value or left plus right, and I can take a max of this because root dot value means I have picked root, and left plus right means I really haven't picked root. But if I do that, then in this case, would return 2 as the maximum, and right sub tree would return 9 as the maximum. So my answer is going to be 11. That makes some sense, but is it going to work? Let's try some other subtree. 1, 2, 3, 4, 5, and 6. Now we're going to do the same thing. The left subtree would return 4, the right subtree would return 11. So the answer here would be just 15, but my correct answer is 16 because I might want to choose 4, 1, 5, and 6, which makes up for 16. So a recursive solution where I would just use this condition is not going to work. Now I know the expected time complexity is O number of nodes in the tree, O of n. Hmm. Maybe the most hard-coded recursive solution. In that solution only, I should be using dynamic programming. I could do that, suppose, but once again, maybe I can use dynamic programming in the most hard-coded solution, and that is the ideal solution. So this is the solution where I'm checking if flag, which means so there is one case when I'm taking the root, another case when I'm not taking the root. When I'm taking the root, let's say, in that case, I have to go for the left of the left. So I have to go for the next part. Okay. So X could be max of get some left side of this and get some. So it's for the left ka left and right. True. Left ka left and right. False. Then I have to do the same thing for right. Right ka left and right. True. Right ka left and right. False. Uh-huh. Otherwise, I will return max of root dot left. Will it even work for this particular case? How do I try my own test case? It's gonna be 1, 2, 3, 4, and 5, 6. Okay, it's compile and run. So that's not working because I'm missing some test case. When I'm taking one, so when I'm taking one, I want to check if my left child is present. Okay, and if my left child is present, then I can go to the left and right side of that left child as selecting both of them or as selecting none of them. So it's gonna have a lot of conditions. That's what I can think of. Yeah, that's what I can think of. So let me try to get it down here so it can make a lot more sense. The same thing I'm gonna do once again. Alright, so now I have left of left, left of right with true and false. Let's say false and true. Or maybe this is left of left with the false, false case. This is left, right, so that's the same thing. Let's just do true here and true here. Phew, I guess this is it. Now I have to do the same thing for the right subtree because I'm pretty sure that this is not a very optimal solution and I would not get a good result if I just do this. I might get my answer, but this is not how it's supposed to be done. Oh, I still didn't get my answer. Why? Because I have to add more stuff even here also. Same logic. I have to cover all the cases now, which is annoying. So this is true, true, this is false, false, this is true, false, this is false, true. So now I've written a lot of stuff and it still doesn't work. Why? Why would it not work now? Alright, just screw it. We have to write a better algorithm because either way that wasn't a very nice looking algorithm. कुछ और सोचते हैं. We have to think something else. Hmm. Hmm. Maximum sum of non-adjacent nodes is. Hmm. Hmm. We need to update this disgusting approach somehow. So let's try to update it. We have a root and okay. All right. Now what I can do is just return get some root. Let's say I say that there could be two possibilities. We take root. Then my sum is gonna be root dot value or instead root dot data. And now since I've taken the root, I can't take its children. So I have to get the sum from root dot left dot left. This would happen if left root dot left is not none, right? So that would be my sum. So I can simply say sum plus equal to, right? I can add. And if root dot right is not none, then I can once again say get sum root dot right dot. Okay, that doesn't make much sense. So it is supposed to be get some left of left plus get some root dot left dot right. Now it's gonna be right dot left plus get some root dot right. Okay, so this is when we take the root. We don't take the root. If we do not take the root, then this gonna be, so we can simply say maximum of sum comma, otherwise it's just gonna be root dot left plus get some root dot right. So if I compile it, this code is also doing exactly the same thing. Now this won't get submitted if I just submit it right now. I have to write cache in order to protect myself from the, okay, it says cache is not defined. That's outrageous. Do I have to import cache now? I mean, I might do that. I might import cache. But let's try to memorize this solution manually. How will I memorize this solution manually? Well, I can have a uh, hash map that, and before I do anything, I can say if hash map dot get root comma -1 is not equal to -1, then you can sort of return hash map of root, right? Otherwise, otherwise you can say hash map of root is this, and you wanna return hash map of root. But I have to improvise it even further. I have to say hash map of root dot left. No, hash map of root dot left is this. Similarly, I have to say hash map of root dot right is this. And hash map of root is this. Now I can submit. Your code's output is 7, its correct output is supposed to be 14. I almost thought that's the right solution. Where did I fuck up? It says 7, 9, and 5. The correct output is supposed to be 14. Do I not have a correct output? Because, yeah, if I take this, then I have to run it on this, so my entire sum would be nothing but 7. Otherwise, if I don't take this, then I have to run for them, root dot left and root dot right. Did I fuck up somewhere? Probably. But where? Was I not supposed to do this? Because what does it say? It says that root dot left is nothing but this. That's a bit ambitious. Let's just replace it by this code once again. But then won't it be giving me time limit error or something like that? I don't know. Maybe no. Maybe not, because I still have a hash map. Let's submit it. Yay, we did it. So just memorize the recursive solution. It's a pretty easy and straightforward problem. So before I solve the next problem, let me figure out if I need to go and study for my exam right now, because it's already 7:16 and I'm really worried now. Um, just give me a second. Let me make a quick call. हेलो, क्या कर रहे हो? हाँ, नील, अरे कब पढ़ोगे तुम लोग वो बताओ, कब पढ़ोगे? कितनी देर में, कितनी देर में? हम्म। ठीक है। ठीक है। ओके। All right. Okay. Sorry for the delay. I still have about 20-30 minutes. Mm, so what are the options? What are several things that we can do in the next 20-30 minutes? Because I don't want to end the stream right now. I still want to keep going. Um, but I do not want to solve problems on Geeks for Geeks. So thank God this is from Lead Code. I have a bad history with this particular problem because I have tried solving this problem for a long time, but I could never really figure out how to solve it. Though it's just a medium level problem, but I am having a really hard time with this problem. So let's try to tackle it today and let's hope for the best. Let's hope that I'll be able to solve it today instead of just wasting a lot of time. Mm, okay. So the problem says that we have been given a number array, return the length of longest arithmetic sequence in nums. Um, a subsequence could be anywhere. So, okay, I have to return the length of longest arithmetic subsequence from my array. So let's say the array is 3, 6, 9, and 12. Well, this is a very bad example because everything makes up a nice little solution. So what else do we have? By the way, do we have other pen? We do. We have a lot of different colored pen. Maybe let's use this light blue thing. Okay, now let's say the array is 9, comma 4, comma 7, comma 2, comma 10, and we have to find the longest arithmetic sequence subsequence inside of this array. So if I do it by brute force method, I see that the longest arithmetic subsequence would be so from 9 I can make no, there I have 4, 7, and 10. 4, 7, and 10. So the brute force method for me is basically to start at a number and then check uh, if I take the next number as this in the subsequence, then what is the length? This is going to take O of. So I choose one number, then I pick that, and then I check again. So it's going to be O of n cube. Definitely, I have time 10 to the power 3. If I cube this thing, then my submission would definitely fail. So it's not a so brute force method won't really help us right here, but nonetheless, it's good to know what are we dealing with in the first place and what are we trying to improve upon. So, okay, now think of a better solution. I have some hints already in my mind because I have seen this problem multiple times already. My hint is that I have to loop over the possible values of D. D is the discriminator for this subsequence, or you can say this arithmetic subsequence. D is nothing but AI plus 1 minus AI upon, um, what is it, 1, or maybe just this. Yeah, so this is the D. So if you do an minus ai, then this is going to be n minus I. So this is my D, and now I have to find out what is the maximum length of subsequence that I can form with a particular D. Okay, I might be using a binary search here. So the least value for my D is 0. Is it? Won't it be negative? So yeah, well, it could be a negative integer also, but all the nums are positive, so I can make sure that the least value for my D is gonna be mm, maybe we can take the least number in this subarray and the highest number, and then subtract the highest from the least and get the minimum value, and h minus l would be the maximum value. So this is our low, this is our high. We can start a binary search for this, and for the mid we have to check what is the maximum length subsequence that we can generate from this. um, okay, but binary search is applied on things that are sorted. So is the value of d sorted? Hmm. Yes, it is. So indeed, what I'm gonna do is I'm gonna check if it's possible to get a subsequence. Mhm. With a particular d or not. Hmm. I'm trying to figure out if this is really gonna work or not. Can I use a hash map? I think I can. Hmm. I also I can think of a O of n square solution using hash map. I can simply loop over this range. That would be at max 10 to the power 3, so it doesn't really matter. I can loop over this range and I can check what is the maximum length of subsequence that I can get. Is it O of n squared? Let's see. So if the length is, let's say, if d at some point is 3 and my subarray is 9, 4, 7, 2, and 10, then what I'm gonna do is I'm gonna check what is the maximum length of subsequence that's possible if we start from 9. Well, in that case, I will add 3 and I will check in the hash map if that is there. Um, and I will keep doing that for as long as this is there. And if it's not there, then I will. So this has repeated integers, yeah. Hmm. So this problem will take O of n cube. Never, never mind. I think the good solution would be n square log n, where I change d based on the binary search and n square to figure out what's the maximum length of subarray. That's the solution from my side. Binary search, hash table, and array. Fuck the dynamic programming. I don't think it's really valid here. Now let's just try to think of a better way of finding the max length. Oopsie, I have to go now. I have to go. I'm really sorry. Bye bye bye.